Howdy. So this is question 3 of the 2015 Lincoln High Level 3 probability exam. In a study done on occupational hand dermatitis, 1,500 hairdressers, it was found that 660 had been working at least 5 years, 296 owned their own salon, and 30 owned their own salon and had been working less than 5 years. And the question is, what proportion of hairdressers in the study had been working less than 5 years and did not own their own salon? Now, some people miss the word not and answer the wrong question. So you've always got to read that goal really carefully. Okay, so the first thing we should do in a probability question is represent it on a diagram. And I'm just going to use a two-way table here, because a two-way table is the easiest. Some people call it a table of counts. It's the easiest one to use, so always consider that first, unless you want to make it hard. And the only reason you go away from a two-way table is if you've got more than 2 category variables. But we've only got 2 here. What are they? Well, it's whether you've been working at least 5 years. It's one category variable, and the other one is whether you own your own salon or not. So that's 2 category variables. So we don't need to worry about the 3-way Venn diagram because we've only got 2 things. And then the other diagram you sometimes have to resort to is a tree diagram. But you only resort to a tree diagram if we only need to resort to a tree diagram if some of the information in the question is conditional probabilities. Is it? No, because all of the information, all these 3 bullet points, they're all counts. So it's out of 1,500. So we don't need to go to a tree diagram. So a two-way table is going to be fine. The first question in our two-way table is whether you've been working at least 5 years or not. And yes or no. And we can put 5 plus or less than 5. The other question is whether you own your own salon. So that's going to go down the side. Do you own your salon? Yes or no. And the annoying thing here of course, is that the S looks like a 5. But we'll just have to be careful how we write it. So yes, I own my own salon, or yes dash, no I don't. Okay, sweet. Now the problem is, what proportion have been working less than 5 years and did not own their own salon? So that means, had you been working at least 5 years? No, less than 5, and did not own their own salon. So that's going to be this one here, isn't it? We highlight that first because so many people misread this and got the wrong one. So now the easy part is filling this in because they've given us the numbers, so it's very straightforward. So 660 have been working at least 5 years, so 5 plus that's 660. And why don't you pause the video? And in fact, I'd like you to pause the video, please. And if you haven't done this in the exam, I'd like you to do this now. Fill this table in and hit play and keep watching it once you've had a go at this first question, because we'll go on to the next one and we'll look at how it was marked. So hitting pause. Okay, so I'm hoping you've had a go now. And here's what I got. 296 owned their own salon. Okay, so to answer the question, probability less than 5 and not owning their own salon equals 810 out of 1,500, or 54%, 0.54. Okay, cool. So just over half, and you always make sense of it at the end. And yeah, it is 810 is just over half of 1,500, and check that you've actually answered the question. Yeah, all good. Okay, so question B. 2 different hairdressers from the study were selected, and so 2 different hairdressers, and both were found to have been working for at least 5 years. So we know that they were working for at least 5 years. We know that already. So we know already that they're in this column here. Right, so it's only out of the 660 hairdressers who'd worked at least 5 years. We don't care about the rest. Okay, now it says calculate the probability that both these hairdressers also own their own salon. So, when we're asked for two events, we always start with one. So, for the first hairdresser, out of the two, the probability that they own their own salon, and it should be given that they've been working for 5+ years, because remember we already know that they've been working for 5+, equals 266 out of 660. Right, now you got to achieve evidence just for getting that far. Now suppose remember we're selecting two hairdressers. So after we select the first one from the 660, how many are left? Well, now there's one gone, so there's only 659 remaining. And of those 659, how many own their own salon? Well, only 265. Why? Because we've already used one up. So, for the second hairdresser that we pick, the probability of owning your own salon, given that you've been working 5+ years, is actually 265 out of 659, because we've lost one. So, the probability that both of them own their own salon is going to be the result of multiplying those two probabilities by each other. 266 over 660 times 265 over 659. And we get 0.1621 to four significant figures. And that's assuming what? Well, it's assuming when we multiply two probabilities together, for that to work, we're assuming that the two events are independent of each other. So this assumes that whether each hairdresser owns the salon is independent. Okay, part C. Consider the events. A hairdresser has been working at least 5 years and a hairdresser owns their own salon. Are these events statistically independent? You must support your answer with statistical reasoning. Well, what does statistically independent mean again? Well, events are independent if the occurrence of one event has no influence on the probability of the other event. An example of two independent events are when you toss a coin and then roll a dice. They're independent. For example, getting tails with a coin doesn't change the probability of rolling a 3 with the dice. Your chance of rolling a 3 is 1 in 6, and if you get a tails on the coin, it doesn't change that. An example of two events that would not be independent would be having a job and owning your own car if you're in year 13. Because having a job influences the probability of owning a car. And we know that generally if you have a job, you've got more money and you're more likely to own a car. So putting numbers on that, the probability of, so for independent events, the probability of rolling a 3 on the dice is 1 in 6. And the probability of rolling a 3, given that you just got tails on the coin, is still 1 in 6. Having a job and owning your own car, well, when we did the survey with our class, the probability in the class of owning a car was 12 out of 19, so about 63%. And of those that had jobs, so given you had a job, the probability of owning a car was much higher at 11 out of 12, which was 91.6%. So the test is, events are independent if and only if the probability of A given B is the same as the probability of A. So B doesn't change the probability of A. They're not independent if the probability of A given B is different to the probability of A. So if the occurrence of B changes the probability of A, then they're not independent. Okay, so we go back to the question we're doing. So that's here. And the event, a hairdresser has been working at least 5 years, and a hairdresser owns their own salon. So 5+ years, and we called it S for salon. Okay, so are they independent? Well, the way to know is, does the probability of S remain the same if we know someone's been working 5+ years? So they're independent if and only if that's the case. So they are independent if and only if the probability of S, owning your own salon, is the same as the probability of S given 5+ years. So let's work them both out. Probability of owning your own salon normally is 296 out of 1500, which is 0.1973 recurring. And we want to compare that to the probability of owning your own salon given you've worked 5+ years. So that's out of those that have worked 5+ years, 660, 266 have owned their own salon. So what we're looking for is whether these two pairs of numbers have the same relationship as each other. If they're independent, they'll have the same relationship. It won't matter whether you've worked 5 or more years in terms of whether you own your own salon. So 266 out of 660 is the probability of owning your own salon if you've worked 5+ years. So owning your own salon given that you've worked 5+ years equals 266 out of 660, which is 0.4030. So quite a lot higher, isn't it? So knowing that someone's worked 5+ years has drastically altered the probability that they own their own salon. In fact, in this group, it's far more likely that you own your own salon if you've been working 5+ years, which makes a heck of a lot of sense, doesn't it? If you've been working for a while, more experience, then of course you'd be far more likely to own your own salon. So the answer is no, they're not independent. And the evidence for that is probability of owning your own salon is not equal to, so equals with a line through it, not equal to the probability of owning your own salon if you've been working 5+ years. And that's the answer to the question. We've got our answer and we've also got our evidence to back it up. So if we look at the marking schedule, and for part A, just needed the correct answer, and part A and B were marked together, so to get to merit you needed the conditional probability for, in part B, you needed the conditional probability for both hairdressers correctly calculated. So that was this bit here. And then for part C, also went up to merit, and independence rule used, and correct probabilities used to determine whether you're independent. And as you can see, there's a few other ways you could have done that one too. It's worth practicing independence questions. They do come up a lot, and you do need to memorize what mutually exclusive means and what independence means and the difference between the two and how to test them. That's just something you need to memorize because it will get asked. And it's not good enough to have a rough idea, you've got to have practiced quite a few. So if you go to your New Lake book, and here on the map of the achievement standard, you can see tests for independence, and it says New Lake, pages 47 to 49, and to skip question 81. So definitely do those because you just need to be super crystal clear on that. All the best.